Hey everybody, welcome to Bill Sky, the Java Guy, and today we're going to talk about comments, and we're going to talk about data types in Java. This is absolutely normal when you're learning a new language. Very beginning of the course, that's what you do, so let's just jump to it. Okay, so I'm using Linux here just because it's easier for me, and I'm going to go into my Documents folder, my Java projects, and then I'm just going to create a new project from my template. I'm going to call this one data types. And let's just go in and edit this little bugger. All right. Now, first thing I want to talk about is I want to talk about comments. Now, if you notice in my template, I have this interesting header right here, and this is what we call a multi-line comment. It begins with a slash asterisk. And then every line, every character after that is considered a comment until it closes off with an asterisk slash. So that is a multi-line comment. It can be one line, it can be 2 lines, it can be 8 lines like I have here. And normally what I do is, and most companies do this as well, is that when you create a program, you're going to have all of the information about that program sitting there in your comments when it was created. Like for instance, I'm doing this on the 13th. My programmer's name is going to be Bill Sky, the Java Guy. I even have my compile and run statements in there, and that's just so you know how to do it. And then you're going to put a description of the program in there. I'm not going to do that, but you really should. And also remember, when you have a program in Java, you also need to name the actual .java file exactly the same as your Java class name. So I'm actually going to go ahead and save this, and I'm going to edit my browser, and I'm going to change this name to data types.java. And now I'm going to go back into it. Oh, and it started up with the default browser or default editor. Let's go ahead and make sure I'm always using my Genie editor. All right. So it also has to be the uppercase or lowercase as well. And you have to do that not only with the, well, you don't have to do it with the comments, but it's always a good idea to do that with the comments. And then you want to make sure you also do it in the class. It must be the same name as the file, the class name. Okay. So with that said, that is a multi-line comment. A single line comment, or I should say a comment that begins at a position and goes all the way to the end of the line, is this right here, a double slash. Now this is exactly the same way it is in C and C++. So for those of you that know those languages, it should be pretty easy. And so everything after the slash is a comment. This closed brace is not part of the comment. So that's a single line comment. Okay, so I'm going to go ahead and just build this and make sure I've got my syntax and everything is great. And I like to always go in there and then run it just to make sure it runs okay. And remember, you don't have to put the .class at the end of it, and there you go. All right, so let's jump right into it and let's talk about data types. Now, there's a couple of different data types. There are data types which are only available within the function. And we're going to be talking more about this in future videos. But if I were to put let's put an integer here. This is an int, just like in C and C++. This is an int. The name of the variable is an int, and I'm making it equal to 0. I always initialize my variables to some value. I always do that. I never want to not initialize them because I don't know what the value is going to be, because that part of memory may have some data in it. So I always initialize it to 0. I always also like to put spaces before and after the assignment character, which is the equal sign. So now this data, this integer called an int, is available only within the main function. If I wanted to define it within the class, I could do this. And that means that every function, every method within the class has access to it. In C and C++, that can be thought of as a global variable. But we're not going to talk about that right now. I just want to show you that there is a difference where you put it. Okay, so that's an integer. So that integer is 4 bytes in size, So this integer is 4 bytes, or about 2 billion, a minus 2 billion, all the way up to, generally a plus 2 billion. So that's the range of values that that integer can have. Let's do another one. Let's do a short. So a short is much shorter. It is 2 bytes in size. And that can be anywhere from 32,768 all the way to a positive 32,767, I believe. So that's the range that that short can have. And this is all based on the number of bytes each one of these data types uses up. Let's do a long. So what is a long? A long is 8 bytes, or, and this is a huge number, hundreds, thousands, million, billions, trillions, quadrillions, sectillion. It's anywhere from 9. I don't know. I'm going to type everything in there. 0. It goes all the way to that. Now it is larger. It's actually 9,223,372, but all the way that to about the same thing. I'm not going to type it all in. It's a huge number. This is an absolutely large number. Now, why would you pick an integer over a long? Because the more longs that you choose, the more memory you take up, and possibly your program could actually run slower, and you're wasting space. You don't necessarily want to do that. Also, some functions or classes that you might be using don't use longs. They'll use an integer. So you have to figure that out depending upon the code you're doing. So that's a long. And there's also a byte, and this is literally 1 byte, or minus 128 to 127. I mean, why not? If you've got a counter that's only going to count up to 10, why not make it a byte? Why not make it really, really small so you save space? It's not using a lot of memory. It's not using, just not using a lot of memory. So those are integers. The next thing I want to talk about is floating point. There's basically 2 types of floating point data in a Java program. There's the float, and when you initialize a float, you want to make absolutely sure that you put a value that is a float. Now, any literal, like for instance, this literal right here, the number 0, that literal 0 is actually an int. It's actually an integer. So what's happening is that the interpreter is converting this int into a float because we say float there. So a float can have a value. A float takes up, I believe it's 4 bytes, and it can have anything plus or minus 3.40282 times 10 to the 308th power. Very, very large, or a very, very small number. Then there's a double precision. This is considered a single precision float. Then there's a double precision float, and that's 8 bytes, or plus or minus 1.797, blah, 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 10 to the 308. And actually, the first one isn't 308, it's 38. Sorry about that. So a float is big, but it's much bigger. It's very big or very small, but it's 10 to the 30, or 10 to the minus 30. And a double is a factor of 10 larger than that, I would say, or more than that actually, because it's a power of 10. So that's a 308. So why would you pick a floater over a double? Because you need that accuracy. It's not necessarily that they can't contain the same number. It means that a double precision actually has a better accuracy of the number, especially in the fractional points. So what do I use the most? I use floats quite a bit. I've seen a lot of programmers use doubles. We're talking anywhere from 4 bytes to 8 bytes. It also depends on how big you want your program to be when it's running in memory. So now, if you want any information about how floating points work, I'll try to remember to put a link to my floating point assembly language video in the description of this video so you can get more details on how that works. Okay, so that's floating point. Now, I mentioned something a little while ago about these initialization values. That's an integer. So what is the interpreter doing? It's converting the value, integer value 0 into a float. This is converting the integer value 0 into a double. If you want to force it to the literal itself, the number 0 to be a float, you would put an F at the end. Then that conversion doesn't happen. It's already a float because it ends with a 0. You might also want to put like 0.0. Down here, that's an integer. How do I convert that to a float? I would say 0.0, but I don't want to make it default it to a float. I want to default it to a double. And by default, 0.0, the literal 0.0 is a double. And so that's all you have to do. These are fine. And now why am I going through all of this? Because I want my program to behave as efficiently as I can. So by doing little things like this, you're helping improve the efficiency of your program. Okay, so that is integers, that's floats. What about what do I want to say? Constants. A constant is a variable that cannot change. Anywhere in here, I can say a float equals 123.45f. I can change a float. Once I define it, I can change it. Now let's go ahead and save this. And the reason I want to build this is I want to show you what's going to happen. Okay, so when I create a floating point number, or any variable for that matter, it can be changed. Anywhere in the program it can be changed like there. But what if I want it to be a constant, which means it'll never be allowed to change. It'll always be 0 in this case. Well, the way you do that is you put the word final. Now in C and C++, you would put the word const, C-O-N-S-T, but in Java you would put the word final. So let's go ahead and save this. And we get an actual error on this line of code right here. Why do we get that error? Because we're trying to change the constant a float. We're trying to change its value. So we get an error right there. And that's all she wrote. Okay, so I'm going to comment that out just so the program will compile. And that's constants. Just put the word final in front of everything. Why would you use constants? Well, what if you're going to be allocating an array that's going to have, and we'll talk about arrays later on, but for those of you that don't know what they are, an array is a variable name that can contain multiple values, and they have a specific size. Like let's say you have an array of the 12 months of the year. That array is going to be 12. It's always going to be 12. It's never going to be 13 because we don't have a 13th month. So why would I want to make that a variable? Just make it a constant. Constants actually help your program use up less memory because this constant right here does not really take up any memory space when your program is running. It's mainly used for the interpreter. So constants are very, very useful. So you definitely want to do that. Okay. So let's go ahead and use some of these. And let's get rid of that final just so we can play around with that. So let's go ahead and do something. I'm going to say a double equals 123.45. Because the literal 123.45 is a double, no conversion has to occur. I could also do this. I could use scientific notation, 1.2345, and then I could say e plus 2. And that's exactly the same 2 lines of code. This line of code is exactly the same as this line of code. Let's go ahead and save and build that. Let's run it just to make sure everything is cool. Everything looks good. And now let's go ahead and print it. So I'm going to say print, or system, sorry about that, system.out.println, value of a double is, and now pay attention to this. If I want to add a double to this printout, I would say plus a double. So it's the plus sign here is concatenation. And Java is a little bit different. And there we go. So the value of a double is 123.45. Okay. One other thing I want to talk about with data types is how can you figure out what the data type is of a variable? Let's say you have a program, or you have a program that's using this particular class, and it doesn't know what the data type is. Well, I can use a little thing, and let's go ahead and do a print the data type of a short is, and I'm going to say, because everything in a Java program is an object, and we'll talk about object-oriented programming in a future video, is an object, I'm going to say, use the function and int, or yeah, is it an int? Do I want to, no, I want to do a short. So I put in the variable name. So I want to say to the interpreter, I want to get the object for the variable a short. I want to get the class name. I want to get the class, and then I want to get the name, and this will print it out to the screen. Let's make sure I've got that right. I think I do. Oh, what did I do wrong? Oh, actually, you don't say dot, you say the object a short. So you just say object a short. We're going to be talking about periods and how they're using, but basically what I was saying was that I want to get the function, or I want to execute the function of the class object called a short, or the variable of class object. We'll talk about that more later on in another video, but get rid of that period, and then we'll go ahead and build it. It should work now. And there it is, and let's take a look. And there you go. The data type of a short is a Java lang short. Another way you could do that, if you don't like the Java lang short, you could say get simple name. So there's another function here called get simple name. And you can see that it just says short. And why would you want to do that? Well, you might want to check. You might want to ask, if this variable is short, I want to make sure I don't put something too big into it, or I want to make sure I don't put something too small into it. All right, so that is an introduction to some of the basic data types within Java, and also comments. Don't forget, use comments. They're unbelievably useful. I've been complimented many times by developers that have taken over my code in the past. Thank you so much for documenting your code. You made it so easy to use. You'll get a good reputation by doing that, and it doesn't really take that much time, and it helps everybody out. And the data types, we're going to be playing around with much more data. We're going to be playing around with many more functions, all these periods that you see in the code. We're going to be talking about all that in the future. So until then, keep on coding in Java.